Alright, here we go. Everything that we've done so far culminates into what we're about to do now, which is sketching using calculus. So it's sketching some weird and difficult curves that you would never have been able to do previously, but we can now using calculus and the many applications of it. It is a very long process. I call it the process. It's a very long process, but it's all the stuff that we have done, and it's systematic. I'm going to show you a step-by-step guide to how to do these questions. Now, when it comes to the HSC, there's always at least one of these questions in the HSC paper worth about 8 or 9 marks total. Normally, they will break it up into a few separate questions, which is this process. But if not, I want you to be able to know this process that well that you can just work it through without prompting. So here goes. When we're going to sketch a curve using calculus, the first thing we got to do is find y dash, y double dash. Find our three derivative functions. Find our stationary points. Determine the nature of these stationary points. Find our POIs and test them, which we unfortunately, frustratingly have to do. And finally, once we've done all of that, we can sketch it. So each of those processes individually, we've done before in our previous lessons. Now we bring it all together in one-off questions. So let's just go through that process again. I'll explain each part. First thing we do, as I said, is you find the derivatives. Y dash, y double dash. We then find the stationary points, and we do that by letting y dash equal 0. So once we've found our three equations, we let y dash equal 0, it'll give us our stationary points. What you do is you sub it back into your y equation to get the y coordinates. So you've then got your coordinates of the stationary points. You then want to learn what type of stationary point is it. That should just be the natural instinct. Alright, we found it, but what type is it? So we have to determine the nature. So you should know this part well enough by now from a second derivative lesson. But if not, you sub the x value of the stationary point into the second derivative. If that value that you land up getting, if the second derivative value lands up in positive, you say it's greater than 0, which means you're happy, which means it's a min. Less than 0 would be sad, which would be a max. So it's that like logical flow. But if that isn't ringing a bell, go back and review the second derivatives lesson. We then need to find the POI, or the possible POI, and we do that by letting y double dash equal 0. That way we get a possible point of inflection. We do have to test it, though. We do need to prove that the concavity actually changes on either side. So we do that little manual box with x and y double dash, and we test on either side of this point of inflection and see what happens. We just need to show that it goes from positive to negative or negative to positive. So you can do that quite accelerated. You don't need exact numbers in terms of how positive or how negative. You just need to show that it changes. Once you've found that, then sub that back in, that x coordinate back into our y, and we get the y coordinate. And now what we do is we go and sketch it. We go plot our points and then connect the dots, as I like to call it. And you'll see what that means in practice soon. So let's give it a go. Let's try one example, and you'll see it is a lengthy process. But if you just follow these steps in this system and go one step at a time, it's long, but it's easy. So sketch f of x equals x cubed minus 3x squared minus 1, including all stationary points and points of inflection. So that x cubed minus 3x squared minus 1, we would not be able to sketch that normally. We haven't learnt what that looks like. It's a cubic type of curve, but not just a cubic curve. It's a tough one. But we're going to show you how we can actually go about doing it. So let's go through our steps. As we said, we found our y dash, and our y double dash. So our y, or f of x, is x cubed minus 3x squared minus 1. So our f dash x will be 3x squared minus 6x. So f double dash x will be 6x minus 6. All just basic vanilla differentiation. I then put a box around that because it makes it easier to reference down the track. When I've got them all there, I can just go back to my box and pick and choose which equation I want to use. Next, we find our stationary points. And you should be saying it should just be instinctive. Stationary points occur when f dash x equals 0. That should be really natural by now. So 3x squared minus 6x equals 0. We then take 3x out as a common factor, leaves us outside of x minus 2. And so we know with quadratics that we solve 3x equals 0 and x minus 2 equals 0. So x equals 0, and on the other one, x equals 2. So those are our two potential stationary points, the x values. What we want to do to get the y values is you sub them back into our f of x. So we'll do f of 0, and you sub it back in, and you'll end up getting minus 1. Our f of 2, when you sub that back in, it's 2 cubed minus 3 into 2 squared minus 1. I don't try to do any of that in a step. I just sub it in the first one and do the work in the future steps. So that leaves us with 8 minus 3 into the 4, which is minus 12 minus 1, which gives us minus 5. So our two stationary points are 0, negative 1 and 2, negative 5. Okay, what's next? Well, you should be thinking, when we found our stationary points, we always want to know what type of stationary point. It's not enough to just know that it is one, and we need to know what type. So we determine the nature. How do we determine the nature? You sub it in to the second derivative. So we're going to sub those into the second derivative. F double dash of 0 is 6 into 0 minus 6, which is negative 6, which is less than 0. And if the second derivative is less than 0, it means you're unhappy, it means you're sad, which means you're a max. Look at my systematic logical flow there. Let's try the other one. We've got f double dash of 2 into 6 into 2 minus 6, so that's 12 minus 6, so that's 6, which is greater than 0, which it means you are happy, which means it's a min. Not risking anything, not taking any skipped steps there, just going systematic one at a time, working the process through. So we've got a min at 2, negative 5 and a max at 0, negative 1. Going well. All right, next we find our POIs and then test for it. So our points of inflection occur when the second derivative is equal to 0. So when 6x minus 6 is 0, when 6x is 6, when x equals 1. That's when a possible POI occurs. So what we do, we're going to sub that back into our f of x. We'll just get the y value. So that's 1 cubed minus 3 into 1 squared minus 1. So it's 1 minus 3 minus 1, which is negative 3. So we've got a possible POI at 1, negative 3, which is now what we're going to test. And as you can see, I've drawn up the x, f double dash x box there. 1 is what we're testing. We need to test just either side of that. The closer to it, the better, obviously. I've just taken a half on either side. So we need to sub in 1.5 and we need to sub in a half into our second derivative. When we sub in a half into our second derivative, well, you can actually do it in your head there. 6 times a half is 3 minus 6 gives us negative 3. But remember, it's not important how negative, it's just important of what the sign is. So that's a negative. Let's sub in 1.5. 6 times 1.5 minus 6, well, that's clearly going to be positive. The answer is going to be 3, but again, it's not relevant. You just want to know, is it going to be positive or negative? That's going to be positive. Therefore, you can say the concavity changes. And as such, we have a point of inflection at 1, -3. Making sense? Okay, that's it. Now we're ready to sketch it. So we draw out our axes. Now in real life, the sketch is going to be a lot bigger than this. Usually I like half to a third of a page. Rather be big and be able to mark everything and draw it than too small and trying to squeeze it in. So always at least half to a third of a page. Okay, now what we do is you plot all the points that we found, and then as you remember, we play connect the dots. So what do we know? Well, there are our points, our key points that we're going to plot. So let's put all of those down onto our graph. There's a max at 0, -1. There's a min at 2, -5. And there's a point of inflection at 1, -3. You can see them all marked there now nicely on our graph. And so we know we've got a little max at the 0, -1 there and a little min at the 2, -5. So we start drawing it. Nothing else is going to happen besides that. So we start drawing it. We go up, we have a little max there. Through there the concavity changes and then a min and up. And there's the drawing. That is that sketch. X cubed minus 3x squared minus 1. That's the drawing. And we did that purely by finding our stationary points and points of inflection and then just sketching it on the back of that.